All right, so this is lesson 1.4, day 1. The section is called Extrema and Average Rates of Change. Today we're talking about Extrema. The next lesson, 1.4, day 2, we'll talk about average rates of change. So our goal for today is I can determine intervals on which functions are increasing, decreasing, or constant, and determine maxima and minima of functions. So go ahead and start with the opener here and use the graph of f of x at the right to answer those three things. Go ahead and pause the video and try it on your own. All right, let's see how you did. Determine the domain and range of the function in interval notation. So domain, range. All right, domain, if I look at all possible x values, I look from the left to the right. It goes from an arrow to an arrow. So negative infinity, positive infinity. My range, I'm looking at all possible y values. So I'm looking the lowest my graph goes to the highest it goes. The lowest it goes is 2, and it includes it. The highest it goes is an arrow, so infinity. Next, I have the limit as x approaches 1. So I'm going to find the x value of 1. And I'm going to approach the x value of 1 from the left. I'm going to approach the x value of 1 from the right, and I'm going to see if I'm approaching the same y value. I am. I'm approaching the y value of 3 from either direction, so the limit is 3. Last one, the limit as x approaches negative infinity. Remember, that's talking about end behavior, and that's as my x values are getting smaller. So as my x values are getting smaller, what's happening to my y values? They're getting bigger and bigger and bigger, so that's infinity. Okay, on to the new material. The first sentence here says, an analysis of a function can include a description of the intervals on which the function is increasing, decreasing, or constant. Consider the graph of f of x shown as you move from the left to the right. F of x is, so now we want to write the intervals on which it is increasing, constant, and decreasing. So whenever you're doing this, you're always looking from left to right. And as you're looking from left to right, if it's going upward, it has an upward slope, then it's increasing. If you look from the left to the right and has a downward slope, it's decreasing. And then if it is horizontal, then there is a constant there. So if you look here, if I want to know on what interval this function is increasing, as I look from left to right, it is increasing from here to here. So if I look at the domain of that piece, it's from here to here. That is from negative infinity to negative 5. Now I'm putting a parentheses on this and not a bracket because let's go to this note over here. When writing increasing, decreasing, or constant intervals by definition, it is on an open interval, so it is open. Therefore, these intervals will always be written with parentheses and never with brackets. Oops, brackets. So another way to think of this is that domain and range are the only thing that could have brackets. Intervals of increasing, decreasing, constant will never have brackets. All right, where is it constant? So let me switch colors here to color code. It is constant from here to here. So that interval is from negative 5 to 0. And then last but not least, where is it decreasing? So it's decreasing from here to here. So that is from 0 to, and then I drew through it, so I'm not sure, 5. 0 to infinity. It doesn't stop. It keeps going forever and ever. There is nowhere where it stops. So from 0 to infinity. Once again, arrow there, so 0 to infinity. So another way of looking at this, or another way of thinking about it, is when you're given the interval, you're going to be given the domain, giving the domain of that piece. Okay, so here it just describes what increasing, decreasing, and constant means, and I just described them to you, so we're not going to read through that. All right, let's talk about relative minima and maxima. So I already wrote out the definitions, but I'm going to read through each just to make sure you understand. A relative maxima. It's the value of f of x. So first off, the value of f of x, remember that's just the y value. So your answer is always the y value of when a function changes from increasing to decreasing. So think about what that looks like. Here's increasing, here's decreasing. So this will look like a hill. So there's increasing, there's decreasing. Whatever this y value is right here, that's a relative maxima or relative maximum. Both are said both ways. A relative minimum is the value of f of x, so once again the y value, when a function changes from decreasing to increasing. So this will look like a valley. So there's decreasing, there's increasing, wherever that y value is, that's the relative minimum or minima. The absolute maximum is the greatest value f of x reaches over its entire domain. So if my graph looked like this, like that, okay? My relative maxima, I would have this one here, 1, 2, 3, 4, 5, 6. But the biggest, the tallest one, the highest y value would be my absolute maximum. So this is my absolute maximum. Same thing goes with minimum. I would like to not to use my example for that because they all look like they go the same lowest y value. Okay. All right, last, a point of inflection. I'm just going to tell you what this is because I don't want you to confuse a point of inflection for a relative minimum or a maximum. So I'm going to draw an example of what this looks like. So notice this is increasing, and then the graph is still increasing, but it changes direction. So people, it changes shape. So people accidentally confuse this for a minimum or a maximum, and it's not, because notice it's going from increasing to increasing. Same thing like here. This is going from decreasing, and it's still decreasing there. So that is what a point of inflection looks like, and the point of inflection would be this point right here where it changes shape. Okay, so here's our first example. I want to know on what interval is it increasing, decreasing, and constant. Okay. So we'll start with increasing. Okay, so I'm going to look from left to right, and I want to see where it has, it's increasing. Sorry for stumbling over my words. So if you look right here, the graph is increasing right there, and that's the only place it's increasing. So now I'm going to state basically the domain of that piece, and that's the interval. But once again, I'm only using parentheses. So that's from -2 to 0. Now, let's do the interval or intervals on which it's decreasing. So let me change colors here. It's decreasing here. It's decreasing here. So now I'm going to write those intervals. The first one's from -4 to -2. And then there's a union because also I'm going to say that it is decreasing from 0 to 1. Last but not least, where is it constant? Constant from here and then forever. So it's constant on the interval of 1 to infinity. Next it says what's the relative minima and the relative maxima. In parentheses we have the word local there because some books call it local minimum, local maxima. So what you're looking for the local minima, let's do minima, maxima, is from all of your relative minimum, maximum, you're looking for the lowest and the highest. So let's look, and first I'll use, let's see, the highlighter of yellow to do all my relative minima. Okay, so this goes from decreasing to increasing, right? Decreasing to increasing, so this is a relative minima. And then nowhere else on my graph does it go from decreasing to increasing, right? So people will accidentally say that this goes from decreasing to increasing. It doesn't. It goes from decreasing to a constant. So that's my only minima, so it has to be my absolute minima also. So your relative minima is the y value of 0. Now let's do relative maximum. Okay, so I'm looking for anywhere on the graph that it goes from increasing to decreasing. So increasing to decreasing. This right here is a relative maximum. There are no more places where it's increasing to decreasing, so there are no more relative maxima. People will always say that this is a relative maxima, but it goes from nothing to decreasing. So that is not a relative maxima. So the only relative maxima is 2. Okay, so now we're going to look at 3 different graphs here, And we are going to do what we did today, which is describe how it's increasing, decreasing, and constant, on what interval it's doing that, but also refresh our brains with domain, range, even, odd, neither. So go ahead and pause the video and try this example on your own, and then just compare answers with me and see if you have any questions. All right, my domain, I'm going to start with how far my graph goes to the left, and it's forever in the negative direction, so that's negative infinity. And now I'm going to keep continuing here. It keeps going and going and going and going. And then my graph stops right here, and there's absolutely no x values at -2. So I'm going to put -2 and put a parentheses there. Then it picks back up, and it keeps going, keeps going, keeps going, keeps going, keeps going. It stops, though. I went too far. Keeps going, keeps going, keeps going, keeps going. And then it stops right here at this x value. That x value is 9. Okay, so I'm going to say union picks back up at -2 and then goes to 9 and stops. And there is an x value at 9. So what people accidentally do at first is they'll say negative infinity and then they'll say it stops here. But there's a value there, so you don't stop there. Okay. Now my range, I want the lowest my graph goes to the highest it goes. So here's what people accidentally do. They'll say lowest the graph goes is -6, which is true. But then they'll say the highest the graph goes is 9, which is not true. The highest the graph goes, notice there's an arrow pointing right here, as it keeps going. It's just that the physical piece stopped right there, but the arrow on the end implies that it goes forever. So it goes forever. So my range is -6 to infinity. Is it even, odd, or neither? Well, we rearranged notes, so you can't answer that yet, can you? Or did we not rearrange notes? We didn't, so you know what even, odd, or neither is. Okay, so even, odd, or neither. Even is when it's symmetric over the y-axis. Odd is when it has 180-degree rotational symmetry, and neither would be neither of those. If you look at this graph, it is not symmetric over the y-axis, and it's definitely not having 180-degree rotational symmetry. So this is neither. All right, where is it increasing? So once again, I'm going to color code here. I'll use blue for where it's increasing. So increasing here. It is increasing here. All right, so I'm going to say the intervals on which it's increasing. That's -6 to -2. Sorry, that's -6 to -4. Stops right here, right? Union. And then this piece right here is from -2 to 3. -2 to 3. -2 to 3. All right, decreasing. I'll use green for that. Decreasing. It's decreasing here. It's decreasing here. It's decreasing here. So I have 3 intervals on which is decreasing. So this first piece, the domain of that, is negative infinity to -6. Union. My next piece is decreasing from -4 to -2. My last piece is decreasing from 3 to 9. 3's right here, 9's right here, just in case you don't see where I'm looking at. Where is it constant? There are no places where it's constant, so it's not constant at all. None. Relative minimum, right? So I need to find my relative minima. So any place where it's going from decreasing to increasing. So color coding is going to help here. Anywhere it's going from decreasing to increasing. So it's going from decreasing to increasing here. Decreasing to increasing here. And that's the only 2 places. This is not a relative minima. It's going from decreasing to nothing. So let me back that one up. The y values are -1 and 2. Relative maxima. Relative maxima, I'm looking for it going from increasing to decreasing. So increasing to decreasing right here. Increasing to decreasing is right here. And those are my only 2 places. So those y values are at 5 and 9. So 5 and 9. Okay. All right, go ahead and pause the video and try the next 2. and then come back and check your answers here. All right, so this one right here, your domain, negative infinity to positive infinity. If you said that it stops at -1, realize this, negative infinity, it stops here, but there's a point at -1, so it technically picks back up and then keeps going to another arrow, so that's forever. All right, my range, the lowest my graph goes to the highest my graph goes. So the lowest my y values go are right here, which is -3. The highest is an arrow, so -3 to infinity. Tell whether the function's even, odd, or neither. There's no symmetry to this at all, so neither. Where is it increasing? Okay, so I'm looking for where, let's color code again, I'll do purple. Increasing from here to here, it's increasing. So there it's increasing, and it's not increasing anywhere else. So that's from 0 to infinity. Where is it decreasing? Right here. So that's from -1 to 0. Where is it a constant? It's a constant right here. So that's from -infinity to -1. Relative minimum. So I'm looking for places where it goes from decreasing to increasing. That's right here. That's at a y value of -3. Relative maxima, I'm looking for a place where it's going from increasing to decreasing, which is nowhere, so there's none. This one right here, my graph starts at -5. And it keeps going, 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 and then it stops right here, and it doesn't pick up vertically from it. So now I have to say my graph stops right there at 1, but includes 1, union. It doesn't pick back up until 2, but it doesn't include 2. And then it keeps going, 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 and it stops at 5. It includes 5 because there's a point there. All right, so my range, the lowest my graph goes, -2, comma, keeps going, 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 going. There's still y values here. So like some people want to say there's no y values here. Yes, there is. There's a y value right there. Keeps going, 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 stops right here, which is 4. So hopefully me scribbling all over it is helping people. Okay, even, odd, or neither, there's absolutely no symmetry to this, specifically no symmetry over the y-axis, and there's no symmetry about the origin. So this, once again, is neither. Where is it increasing? So increasing from here to here. That's -2 to 0. And that's the only place it's increasing. Where is it decreasing? It's decreasing from here to here. It's also decreasing from here to here. This is open, but still, it's still decreasing. So that is from 0 to 1 and 2 to 5. 0 to 1 and 2 to 5. Where is it constant? It's constant at that red piece. So -5 to -2. Relative minima, I'm looking for where it's going from decreasing to increasing, and that's nowhere, so none. Relative maxima, I'm looking for where it's going from increasing to decreasing, and there's one of them right there, and that is 4. Okay, last but not least, it says use your calculator to find the following information. So just so you realize, this is using your calculator is not on the test, but we do have later in later chapters where you have to do this using a calculator. So we wanted to introduce it to you here. So I'm going to introduce it to you. So I'm going to, this app right here is Calculate, it's called Calculate 84, and it is a graphing calculator. It's very similar to the TI-84. So if you haven't purchased your TI-84, you can use this, okay? It says use the calculator to find the following information for g of x equals x to the 4th minus 5x squared plus 2. So I need to put that into my graphing calculator. Okay, so to put this into my graphing calculator, I'm going to hit the y equals button, which is right above the blue second button on my calculator and yours. Now I'm going to enter the function. So I need x first. X is directly below the mode button. So it says X, comma, T, comma, theta, comma, N. That's X. Now I need to the fourth power. So I need the caret button. The caret button is located directly above the division button. Fourth power. Make sure you hit the arrow to get out of your exponent. Minus 5x squared. Get out of the exponent, plus 2. All right, let's see if we hit graph, if our graph will appear fully on the screen. And it did. If yours didn't, then you have to hit zoom standard, which is option number 6, and it'll bring it to that graph paper. All right, let's do a quick sketch of what this looks like here. So there's a point here, down here, down here. All right, I'm gonna try to go through all of those. All right, and realize there's arrows that go on forever and ever. It's just that the calculator stopped, so it doesn't have put arrows on it. All right, what's the domain? Look left to right, all real numbers. What's the range? The lowest the graph goes to the highest the graph goes. So I need to know the lowest the graph goes. So I need to know where those values are right there. So what I'm going to do is I'm going to hit second trace. Let me try that again. Second trace. Notice there's an option for minimum. Okay, that's going to find those minimum points there, and we can write down where they're located. So I'm going to hit 3. Now, if you're using an actual graphing calculator, you're going to go and make this, yours should be flashing this X right here. You're going to make it go to the left of that, that minimum there, and then hit enter. It'll say that was your left bound. Now you're going to move it to the right and hit enter. Now on this graphing calculator, it automatically tells you what your minimum is down there at the bottom. On a TI 83, 84, you have to hit enter one more time, and then it'll tell you what the X and Y value are. So this point right here is negative, oops, what just happened? Go back. Negative 1.581, comma, negative 4.25. You would do the same thing to find this. It's symmetric, but just so I can show you here that one more time. Second trace. Option number 3 is minimum. You want the arrow to get closer to this one. So now it's to the left, and because it's asking you at the top for a left bound, hit enter. It's asking you for a point to the right. So here's a point to the right, hit enter. And then if you have a regular graphing calculator, hit enter one more time. But your minimum is, the other minimum is 1.581, negative 1.581, negative 4.25. Shocking, I know. It's symmetric. That's why it's those two that look exactly the same. Okay, so now we know our range. The lowest our graph goes is negative 4.25. The highest our graph goes is forever, so infinity. All right, is the graph even, odd, or neither? So not based on my sketch because it's a little wonky here, but if you look at the actual calculator, it is symmetric over the y-axis, so it is even. Where is it increasing? Okay, where is it increasing? So it is increasing. Let me put it in a different color here. It is increasing from here to here and from here to this arrow. So this piece here and this piece here, it's increasing. So I need to know the domain of those two pieces. So the first purple piece that I traced is from negative 1.581, oops, 2, and then it stops here, which is 0, union, and then the other piece is from 1.581 to infinity. Where is it decreasing? It's decreasing here and here. So from negative infinity to negative 1.581, and then from 0 to 1.581. Constants, there aren't any. Relative minima, there's 2 here and here. You take the y values and it's exactly the same, so negative 4.25. Relative maxima, remember it's where it goes from increasing to decreasing, so that's right here. People will want this to be the relative maxima. It's not going from increasing to decreasing there, it's only here. So I need to know what this y value is. So I'm going to go back to my calculator. That's a maximum. I'm going to hit second, trace. Option number 4 is maximum. I need to get to the left of my maximum. Hit enter. I need to get to the right of my maximum. Hit enter. On a regular calculator, you would hit enter one more time. And it says that is at 0, 2. Notice mine says 0.000004. It's a pixelation error. Yours might say something like 2.3 e to the negative 23rd. Realize that's 0.0000. That is 0. So if you ever see that, realize it's a pixelation error. So that point right there is 0.2. So my relative maxima is 2. Okay, once again, I'm going to repeat myself here. Calculator stuff is not on the test. We just want to expose it to you so that when we get to calculator stuff, you're not like, wait, what is this thing? I don't know what this is. Okay? All right, so go ahead and get started on your next homework assignment. And then you have one more video.